Okay, for our next section here, we are going to be talking specifically about Pythagorean theorem, which is something that we've gone over before or we've seen show up in problems that we've done in the past, but we haven't talked about it specifically and kind of how it works and like all the things that kind of go into Pythagorean's theorem. So we're going to kind of go over that today, but I'm hoping that this won't be anything that's like brand new or super difficult because we have seen Pythagorean's theorem show up a lot. One of the differences though that we'll see is because we now know how to simplify square roots, when we write our answers today, we don't want to have decimals necessarily unless they're unavoidable. Like there's going to be some times where maybe the context of the problems or the numbers that you're working with underneath your square root, it's kind of impossible not to deal with a decimal. But for the most part, if we can reduce our radicals, we're going to want to make sure that we do that. Okay. So can you guys just remind me, what is Pythagorean's theorem? What does it say? Good. A squared plus b squared equals c squared. Okay. And how do you know what the A, B, and C, like if you're looking at a triangle, how do you know what to put in where? Can anyone tell me how to do that? Okay, so you said that A and B are like the two sides on the triangle that create the right angle. Because if I think about just like a little picture of a right triangle here, and that's my right angle, you're saying that these sides would be A and B. Like this one could be A and this one could B, or I could flip them around, right? Good. Okay, have you ever heard a term used for those sides when we're talking about a right triangle? Okay, if you haven't, these are called the legs. Because on a right triangle, we have that third side, which we all would know now has to be our C. And we talked about that even yesterday when we were dealing with that geometric mean and like setting up those triangles. What did we call that C side? What was that name we used? Good, hypotenuse. And so remember, the hypotenuse is always going to be that side that is across from the right angle. It's going to be the longest side that you have on your triangle. Okay. A and B are your legs, and they can be kind of interchanged. Like I could rewrite, so A and B are flipped around if I wanted to, but C always has to be across from the 90. So I'll even just write that underneath here. It's across from the 90 degrees. Okay, can we use Pythagorean's theorem on any kind of triangle we want? No, what kind of triangles can we only use it on? Correct, we can only use with right triangles. So I can't just look at any triangle out there and have Pythagorean's theorem work for it. It has to have that 90-degree angle in order for us to be able to do something with it, okay? So what we're going to do now is get into some problems where we actually solve for the missing sides. We're going to have to figure out like what's our A, B, and C, how we plug this in, and then what we do with it, okay? So let's start with this first one. I would start out by just labeling what's your A, B, and C side so that then we can just plug it into our formula. So what side length here on this example is where my C is? Okay, C is going to be here, right, by the 34. And then we can put A and B on these other two sides. And again, it doesn't matter which one you call A and which one you call B, okay? So now when we plug this into Pythagorean's theorem, it would say x squared, because I'm putting x in for the A side, plus 30 squared, because that goes in for my B, equals 34 squared. Right? Okay, now we're going to have to square these numbers. You might want a calculator for this because these numbers start to get kind of big. But what would be 30 squared? Okay, 900. Who's got 34 squared? Good, 1156. What would you guys do now? Good, you'd subtract that 900, so you have x squared equals 256, and then what? Square root. Can we square root this nicely? If you're unsure, you can always test it and see. You got 16? Good. And then we do have labels here, so I'm just going to make sure I put a label on my answer, especially if we're talking about what this maybe means. You know, if they were talking about something that they were trying to construct, or like the dimensions of a room or a box or a picture frame or something, like they're talking about the corners being square, we should be able to have labels on those if we're giving context here. So 16 centimeters. Good. All right, you guys tell me, what do you want me to do for number 4? How do you want me to set this up? Maybe tell me how to label my triangle first. Okay, A, B, and C. Good. And then how would you guys write it in your formula? Like that? Okay, perfect. What's 6 squared? And 12 squared would be 144. Okay, when we add those together, we get 180. Can we square root 180 nicely? No. Okay, so now we're back to, I don't want a decimal. Okay, now we're going back to, how do we simplify these square roots? How do we start to work with that? Okay, so you got to think about what's the biggest perfect square that you can find that would go into 180. You know, 4 might work, or 9 for sure would work, but I don't think 9's the biggest. Is there a bigger one that you could put into 180? Okay, someone's saying 36 times 5. Okay, I think 36 is going to be the biggest one because 5 is not a perfect square and there's not going to be anything I can do with that. So what is the square root of 36? Good, that comes out, and then square root of 5 is left, and that's just going to be your x. Oh, I shouldn't have an x squared there. So this would be your final answer. Thank you. Feet. Yes, I need a label. Okay, we just talked about that. So on that one, yes, you could have given me a decimal answer if they had asked for it. Okay, but right now I don't really want to see decimals. I want to see you guys still working with these square roots, simplifying them, trying to get them to lowest terms. Okay, we don't want to see these decimals right now. Eventually, there'll become a time where decimals are going to be used again, but remember, a decimal is like the approximate, it's not the exact. And so like right now I want to know, what is the exact answer? Okay, I don't want to have a decimal as like a guess of what I think it is. All right, let's take a look now at this next one. What do you think I should do for this one? Okay, so I'm going to label it how you guys were saying, A, B, and C here. When we go to plug this into Pythagorean's theorem, my A is this square root of 5 side that I wrote it by. So you're going to take the square root of 5 and you're going to square it. So I'm going to put parentheses around that and then square it. And then you would do 2 squared equals, good, x squared. All right, we know 2 squared is 4, so like that's easy to do. But what would happen here? Anyone have an idea what's going to happen with that? Okay, so you can think of this 2 different ways. You can take the square root of 5 times the square root of 5. Like you could kind of go about it the long-handed way. You could think of it, it's really saying this, right? And since they're both underneath square roots, we can multiply and we get 25. But what is the square root of 25? It's just 5, okay? Something that we've talked about in the past is that anytime something is underneath the square root sign and you take it times itself, or in this case, you're squaring it, that number that's underneath the radical sign is just going to pop out. And so it's just going to become a 5. So if you guys can start to recognize that, it might save you some time instead of having to like write it all out explicitly, okay? So now let's finish this. What's 5 plus 4? Good, 9s. We have 9 equals x squared, and then we would square root, and so we get x equals 3, good, miles. All right, anyone have questions on Pythagorean's theorem? Okay, with your homework today, you're going to receive a worksheet that is just practicing what we did today in class, like just giving triangles. Let me pull those up here really quick so you guys can see them. So this will be the first one that you get. This just has regular Pythagorean theorem type problems on them. Okay, you're just going to set it up, a squared plus b squared equals c squared, and do what we did in class today. The second worksheet you're going to get looks like this. Okay, we're still using Pythagorean's theorem, but these are going to be more applied problems, which means you might need to draw a picture to kind of illustrate what's going on here. These would also be like on this worksheet. I would say it's okay if you can't necessarily reduce the radical, or if they're asking for like an estimate, you could give me a decimal. Okay, so let's just do this first one together. So they're talking about a rectangular patio that's 13 feet by 84 feet. And it says, in walking from one corner of the patio to the opposite corner, how much distance is saved by cutting diagonally across the patio rather than walking around the outer edge? So I'm just going to draw a picture here. We know that this is a rectangle because it's a patio that's in a rectangle form. They're saying that the dimensions of this are 13 by 84. So I'm going to put 13 here and 84 here. And they're saying that they walked from one corner to the other corner. So that'd be talking about the diagonal. So remember, your diagonal length would be going across like corner to corner. Okay. They're wanting to know how long that diagonal is because it should be shorter than these two full sides put together. Like if you were to cut across a room, that's going to be a lot less distance traveled than if you walked around the perimeter of the room. So think about a rectangle. You would know where's your right angle. Right there. So that means that this would be C, right? So do you guys see a right triangle that we could use in this picture? It's this one, right? So we should be able to set up Pythagorean's theorem here. We should be able to say 13 squared plus 84 squared equals C squared. Okay, and then we're going to do the math here. So 13 squared is 169. Can someone take 84 squared for me and tell me what you get? It's going to be a big number. Okay, 7,056, that's pretty large, equals C squared. If we add these together, we're going to have 7,225. And then check and see if you can square root that. Okay, so C is 85 feet. Okay, so that's the length of the diagonal. But let's go back up here to the problem. It says, how much distance is saved by cutting diagonally versus walking around the outer edge? So we're not totally done. So make sure that we read the problem so we know everything that they're asking for. So around the edge here would be this 13 and 84. So if I add 13 and 84, that gives me 97 feet traveled. And the diagonal is 85. So if I subtract, how much distance did I save? Get 12 feet. So I saved 12 feet by walking corner to corner versus going around. Okay. So for all of these all of these problems on this worksheet, I would really suggest that you guys draw yourself a picture, especially if you're not someone who can just read a word problem and like see what's happening. If you need to draw it out so you can see what do you have, what are you missing, and then make sure that you also read the problems carefully because you want to make sure that you're not missing something else that they were asking for, or that you don't stop the question too soon and then actually you're supposed to do something different with it. Okay. All right. I'm going to give you guys some time to work now.